Good morning one and all, welcome to my channel Miracles of Math. So today we are here to start a new course called Applied Mathematics Subject Code 241. Applied Mathematics used to be a skill subject till the previous academic year, and from this academic year, that is 2020-21, this Applied Mathematics is introduced as an elective. Applied Mathematics has some difference in topics when compared to the normal basic mathematics, and in that the first topic we are going to learn is binary system. This topic is not included in the basic mathematics which everyone are taking with the subject code 041. Few topics in applied mathematics are introduced newly so that these are actually applicable in the real life. For example, the first topic, if you take binary system, this has a very prominent role in the present technology. All the computer systems, whatever we are talking about, computers, chips, okay, SIM cards, that is memory cards, whatever you say, all these are related with binary system. Can a computer understand? Can a computer understand the normal language what I am talking with you? No. Can it understand what are numbers? No. But a computer is a machine which can actually understand only two things, on and off. A computer can understand only on and off. If you on the switch, the power supply will start and it gives some signal, and if you off it, no signal will come. So on is actually represented with the number 1 and off is represented with the number 0. Binary system, binary means 2. Binary system has only 2 digits throughout its subject, that is 1 and 0. All the other numbers which we actually use in our present decimal system. Okay, let us come to the difference between what is a binary system, what is a decimal system. Binary system is the one which we are using, that is from 0 to 9. The numbers from 0 to 9, 0, 1, 2, 3, so on till 9, we have 10 digits altogether, and that's the reason we are calling it as decimal. DEC, des actually represent for 10, decagon in that way. Okay, so it is decimal system which has 10 digits in that, Similarly, binary system has only 2 digits, 0 and 1. So this is called binary. Bi always stands for 2. So it is binary system which has only 2 digits, 0 and 1. So now you can ask me, sir, how to write then number 2? You have 0, you have 1 with you. So how to represent 2, 3, 4, all these in binary system? Do we have these numbers in binary system? Yes, we have all the numbers which are there in decimal system. We also have them in binary system, but they need to be converted into binary system. So the first topic we'll be discussing here is how to convert a binary number to decimal number and decimal number to binary number, including fractions. Let us come quickly to the first topic, that is how to convert a decimal to binary. How to convert a decimal number to binary. Before that, I will introduce how the numbers are actually written in decimal system and how actually numbers are written in binary system. For example, let us take a number 2020. How do you represent this 2020 in decimal system? See, this is units place, tens place, hundreds place and thousands place. This is actually equal to 2 into 1000, that is 10 cube, plus 0 into 100, that is 10 square, hundreds place, plus 2 is in again tens place. So 2 into 10 power 1 plus this is in the units place, 0 into 10 power 0. 10 power 0, 10 power 1, 10 square and 10 cube. This is actually the representation of a number in its decimal system. The same thing will be applicable to binary system. For example, I don't know, I'm just giving an example. Let us take one number 1101, 1101. See, in decimal system, it is 10 power 0, 10 power 1, 10 power 2, 10 power 3. The number 10 is called the base of the system. Is called the base of decimal system. Similarly, the base of binary system is number 2. So, to get this number, what it is actually 1 into 2 power 0, 0 into 2 power 1, 1 into 2 square, and once again 1 into 2 cube. See, here the base is 10. So, we are multiplying this with 10 power 0, 10 power 1, 10 square, 10 cube. In the similar way, here the base is 2. So, 2 power 0, 2 power 1, 2 power 2, 2 power 3. So, this is whatever the number we get, that is actual decimal equivalent to this binary number. Let us quickly have some examples and we will learn through the examples. Let us take one small number, maybe 24. Let us take a number 24. 24 is in the decimal system, so I am representing with the base 10. This is in its decimal system. Now I want to convert this into some x which should be equal to its binary system. So the base is 2. How to convert this? Very easy. See here. 24 is here, so divide with 2. So you will get 12, and what is the remainder? Remainder is 0. So write that 0 here. Okay. Once again divide with 2. Always you should divide with 2. Always you should divide with 2. 2 ones, 2 6 are 12, and once again your remainder is 0. So once again 2 3s are 6, once again remainder is 0, and 2 ones 2, 2 ones are 2, and you will be left with the remainder 1 this time. You can leave as when you get 1 here, or if you want you can go for one more step, that is 2 zeros are 0, 2 zeros are 0, and you will be left with the remainder 1. You can stop at the step where you get 1 here, or if you want you can go to one more step and write 0 here. So now what is the equivalent binary system for 24 is, you start from this one, all the remainders, start from this one and write from down to up, bottom to top. Okay, so it is 1 1 0 0 1 1 0 0 to the base 2. Base 2 is actually for representing that it is a binary number. It is a binary number. It is not 11,000. It is 11000 in binary system. Clear? You can even stop at this point. That's the point I'm saying. You can even stop at this point and you can start writing from here 11000. The same thing. It is your wish whether to stop at this point or you want to go to one more step after this one. So let us see the equivalent. This is a binary system, the equivalent decimal system, how to convert this binary to decimal system. And if at all we have done correctly, we should get it as 24. Because 24 only we have changed it to binary. So once again, if you convert this binary to decimal, you should get 24. Okay, so let us quickly do that. And I said the base for binary system, is 2. See here. So we have 11000. Okay. So write 2 power 0 here, 2 power 1, 2 square, 2 cube, and 2 power 4. If you have more digits, 2 power 5, 2 power 6, 2 power 7, all those will be added here. So what you do, 1 into 2 power 4, 1 into 2 power 4, plus 1 into 2 cube, plus 0 into 2 cube, plus 0 into 2 square, plus 0 into 2 power 1, plus 0 into 2 power 0. You need to write all those, but all those becomes 0 in this problem. All those becomes 0. 0 into anything is 0. Correct. So what is 1 into 2 power 4? It is 16, plus 2 cube is 8. So 16 plus 8 is 24. So the equivalent decimal number for 11000 is 24. Clear? See, this one you can also write as numbers. This is 1, 2, 4, 6, 1, 2, 4, 8, 16. I'll say you once again. Instead of 2 power 0, 2 power 1, 2 power 2, 2 power 3, all those. Okay. Start with 1 into 2, 2 into 2, 4 into 2, 8 into 2, 16. Just add the numbers wherever you have 1. Add the numbers wherever you have 1. You have 1 here, you have 1 here. So just add these two numbers. 16 plus 8. What is 16 plus 8? 24. The same thing we have done here also. 2 power 4 is 16, 2 cube is 8. Okay, we'll take one more example. Let us take 1, 1, 1, 1 in binary system, and we want to convert this into some x which is equivalent decimal system. Clear? So write 1, 1, 1, 1 and start writing here 1, 2, 4, 8. What are these 1, 2, 4, 8? 2 power 0, 2 power 1, 2 cube, 2 power 0, 2 power 1, 2 square and 2 cube. Clear? And add all the numbers wherever you have 1. Add all the numbers wherever you have 1. So you have 1 on all these terms. So 8 plus 4 plus 2 plus 1. 12 plus 2, 14. 14 plus 1 is 15. So the equivalent decimal system for a number 1111 is 15. Let us quickly verify whether it is correct or wrong. What you will do for verification? So 15 divide with 2 always. Always. That is a rule that we need to divide with 2. So 2 7s 14 and the remainder is 1. Okay. Once again with 2. 2 3s are 6. Once again remainder is 1. 2 1s are 2. Once again remainder is 1. Correct. So starting from here, top to bottom. 1 1 1 1. 1 1 1 1. That is the equivalent binary system to a number 15 in decimal system. Are you understanding the difference between a binary system and a decimal system? Yes? Okay. So quickly, I'll tell you how to write binary numbers till 32. There's a small trick. Okay, so that you can write fastly for the numbers from 1 to 32. You can extend the same thing to whatever level you want. I'll say here, see. I will write 1, 2, 4, 8, 16. If you want to go for 32, you can also go for 32. See here. Number 0 in decimal system as well as binary system are same. 0 is 0. 1 is 1. Okay. 2. How will get 2? See what I will do here. I will write above to this one 1, 2 power 0, 1, 10, 100, 1000 and this is 10,000. See what I will do here. I want 2. 2 is here. What is the equivalent? 10. So write it as 10. I want 3. What is 3? How can you write 3? 3 is 2 plus 1. 3 is 2 plus 1. So 10 plus 1. 10 plus 1 is 11. 3 in decimal system is actually equal to 11 in binary system. Next, I need a 4. 4 you can directly have, it is 100. I need 5. How will you get 5? 5 is 4 plus 1. 5 is 4 plus 1. So 100 plus 1 will give you 101. What about 6? 6 is 4 plus 2. 100 plus 10, 110. 7. How will you get 7? 7 is 4 plus 2 plus 1. 4, 5, 6, 7. Okay. So 100 plus 10, 110. 110 plus 1 is 111. Are you understanding this one? Yes or no? So how will you get 8? No need to add anything. 8 you have here, that is 1000. 8 is 1000. Students, how I got these numbers? 2 is 10, 4 is 100, 8 is 1000. Simply divide with 2. So 2 4s are 8, 0. 2 2s are 4, 0. 2 1s are 2, 0. So 8 is 1 0 0 0. The same thing. Nothing new. Okay. So we have 8 here. How will get 9? How will get 9? 9 is actually 8 plus 1. 1000 plus 1, that is 1001. 1001. How will get 10? 10 is 8 plus 2. 1000 plus 10 is 1010. 11. How we will get 11? 8 plus 2, 10, 10 plus 1. So 1000 plus 10 plus 1, 1011. 1011. Are you understanding? Only with this table we can write all the numbers till we can go till 31. I'll tell you that. So how will go? How will get 12? 12 is 8 plus 4. So 1000 plus 100 is 1100. 13. 8 plus 4 plus 1. 1000 plus 100, 1100 plus 1. 1101. Yes or no? In the same way 14. How will get 14? 8 plus 4, 12. 12 plus 2, 14. 1000 plus 100, 1100. 1100 plus 10. 1110. See, I am not remembering anything. I don't know anything. I am not remembering anything. But using only these values, I can directly write them. 15. How will you write 15? 8 plus 4, 12. 12 plus 2, 14. 14 plus 1 is 15. 1000 plus 100 plus 10 plus 1. 1100, 1110 and 1111. 1111. Just the before example we have seen that. Okay. And how will you get 16? 16 you directly have this as 10,000. 16 you have it as 10,000. 17, 16 plus 1. 18, 16 plus 2. 19, 16 plus 2 plus 1. And you can all write all this till 16 plus 8 plus 4 plus 2 plus 1. That will give you 31. Till 31 you can go. You can write. What about 32? If you go to one more extent 32, it will be 1, 2, 3, 4, 5. That will be 32. So if you extend now, you can even write 33, 32 plus 1, 34, 32 plus 2. In that way, you can go till again 63. You can even extend that to whatever extent you want. Okay, so this is how we write numbers, and these are very important, people. All the basic, at least from 0 to 6 or maybe till 8. Okay, always we come across these numbers, and at that time you should be very confident in telling what is the number. Wherever you see 110, you should be saying it as 6. Wherever you see 111, it is 7. 1000, it is 8. If you carefully observe, 2 is 10, 8 is 1000, 16 is 10,000, and 32 is 1 lakh. Any relation between all this? See, it has only 1 and all zeros, 1 and all zeros, 1 and all zeros. How are we getting this one? It's very simple. See here. 2 power 0. What is 2 power 0? It is actually 1. 2 power 1 is 2. For the number 2 power 1, the decimal system is 1 and 0. 2 square. Now we have 2 here. So the decimal, which is equal to 4, the decimal equivalent for this is, the binary equivalent for this number is 100. As many power you have, that many zeros will come here. This is 2 square. 2 cube. This is 3. So 100. 1000 will be the equivalent decimal system for 2 cube, that is 8. 2 power 4, 16. You have 4 here. So 4 zeros will come here. The same thing, 10,000. Next, 32 is actually 2 power 5. So you will have 1 and followed by 5 zeros. Next, 2 power 6. You will be having 1 and followed by 6 zeros. And in that way, it continues forever. 2 power 7, 2 power 8, 2 power 9, 2 power 10. Okay. Whatever the number here, you will have that many zeros beside 1. Alright. So this is about binary system. Okay. So now your question is, sir, we have taken a number and converted into binary or binary to decimal. What about fractions? We have something like 0.123, 0.345. What about its fractions? Before that, for my convenience, I am writing few values here, which will be easy for me when I am calculating it. Okay. So 2 power minus 1, you know that it is 1 by 2. It is actually equal to 0.5. 2 power minus 2, 0.25. So for my convenience, I have written these numbers 2 power minus 1 to 2 power minus 6. In some values, we may require these values. So at that time, without the loss of time, I have written here. Okay. So now the concept is how to convert a fractional number to its binary equivalent. Let us take one example. See, up to now what we have done, let us say if we have a number 15. If you have a number 15, what we have done, 15 we are dividing it 2 by 2 by 2 by 2 and everything. Okay. And the equivalent for this is 1, 1, 1, 1. And how are we converting this back to the number? Converting a decimal number back to its binary number to its decimal number. Okay. So we are multiplying with 2 power 0, then 2 power 1, then 2 square, and then 2 cube. Yes or no? Now, the same thing will applicable even for its point, let us say 0, 1, 0, 1, 1. Okay, let us say we are having like this. The same thing will applicable, but instead of 2 power 0, 1, 2, now we have to go to the negative direction. That is, multiply this 0 with 2 power minus 1, next with 2 power minus 2, 2 power minus 3, 2 power minus 4, and this is with 2 power minus 5, and this one with 2 power minus 6. The same thing, the same method, but up to now we have discussed with 2 power 0, 2 power 1, all the positive powers. Now we are going to discuss with the negative powers. Okay, so let us see for the number, let us leave this 1, 1, 1. Okay, so let us go for 0.010101, some decimal. This is binary system in fractions. We are converting this binary system to the equivalent decimal system. So we are multiplying with 2 power minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So it is equal to 0 into 2 power minus 1, 0 into 2 power minus 1, plus 1 into 2 power minus 2, 1 into 2 power minus 2, plus 0 into 2 power minus 3, plus 1 into 2 power minus 4, plus 1 into 2 power minus 5, and 1 into 2 power minus 6, plus 1 into 2 power minus 6. Okay, so 0 into whatever it is 0, plus 1 into 2 power minus 2. 2 power minus 2 is 0.25. It is 0.25, plus 0 into 2 power minus 3. It is again 0, plus 1 into 2 power minus 4 is 0.0625. Okay, plus 1 into 2 power minus 5 is 0.03125, and 1 into 2 power minus 6 is 0.015625. Okay, so when you add all this, what you will get? This is 0.25, 0, this is 0.0625, and 0.03125, and 0.015625. So let us add quickly what we will get here. Okay, so this 0 is somewhere here. Okay, so it is 5, this is 7, 5, 6, 7, 7, 6, 13, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, and this is 3. So 0.359375. 0.359375, that is the equivalent decimal number to this binary, 0.359375. Just check if there is any mistake in this calculation. Okay, so this is converting a binary fractional number to decimal fractional number. Correct. Let us see in the reverse way how to convert this binary number, this decimal number, to its binary. Decimal number to its binary. Let us quickly see that. So I am erasing all this. Okay. And when we are converting the decimal to binary, your final answer should be this one. Let us see that. Okay, see here. What you will do, you take this decimal part 0.359375, multiply with 2. Multiply with 2. What will get here? 359375, 2 is 5, 2 is 10, 7 2 is 14, 15, 3 2 is 6, 7, 9 2 is 18, 5 2 is 10, 11, 3 2 is 6, 7. Okay. 1 2 3 4 5 6, 1 2 3 4 5 6. You will get the answer as, see here, into 2 you will get it as 0.718750. 0.718750. Now what we'll do, you write the number, whatever number before decimal here, okay, and write this decimal part again here, 0.718750. Write this number which is to the left of decimal, here, and the decimal part here, the fractional part here, okay, into 2 once again, what will get? 718750 5 2s 10, 7 2s 14, 15, 8 2s 16, 17, 2 1s 2, 3, 7 2s 14, and 1 2 3 4 5 6, 1 2 3 4 5 6, okay. Yes, so we'll get it as 1.437437,500. Okay, so now again the same procedure. What is that? Write this one here, and write the decimal back here. What is that? 0.437500. 0.437500. Once again you multiply with 2. What happens? 4375. I'm ignoring these double zeros. Okay. 4375 2s. 5 2s 10, 7 2s 14, 15, 3 2s 6, 7, 4 2s 8. So it is 0.8750. 0.8750. So once again the same thing. You write this digit here 0 and the fractional again here 0.8750. Once again multiply with 2. Okay, 87502s 5 2s 10, 7 2s 14, 15, 8 2s 16, 17, 4. So it is 1.7500. 1.7500. So what is that number now before decimal? Before that point, it is actually 1. Okay, this 1 will go here, and this 7500, that is 0.75, the decimal fractional part. This fractional part, once again write it here. Once again multiply with 2. So what happens? 0.75 into 2 is 1.5. Write that 1 here, write this 1 here, and this 0.5 here. 0.5 into 2, you will get it as 1.0. That's exact 1. Write 1 here, and as this number is 0, you can stop it here. You should stop when this number is 0. Okay. Even if you go for one more step, writing this 0 here, into 2, 0, again 0, all the other terms will be 0 from there. So now, what is this 0.359375 equivalent in binary system is? Start from this number. Now, don't start from the bottom. Right from here. Okay, from the top only. 0, 1, 0, 1, 1, 1. See here. In this way. It is 0, 1, 0, 1 and 1, 1. And keep a point here. So see here, the same answer we got. Understood how to convert a fractional number in the decimal to binary, as well as from binary to decimal. So once again, we'll take some examples and we'll see all this together from first to last. And this chapter, today's lecture is only about conversions. In the next lecture, we'll be discussing about algebra of these binary systems, that is addition, subtraction, division and multiplication. Okay, so the next question we'll be discussing about 11.101 in a binary system. We'll see what is its equivalent in decimal system. So what we'll do? Write the same thing, 11.101. This one multiply with 2 power 0, 2 power 1. This one with 2 power minus 1, 2 power minus 2, and this one with 2 power minus 3. Correct. So this is equal to 1 into 2 power 1 is 2 plus 1 into 2 power 0. 2 power 0 is 1. So 1 into 1 is 1. Point. Okay. This point will come here. This one, 1 into 2 power minus 1. 2 power minus 1 is 0.5. 1 into 2 power minus 1 is 0.5 plus 0 into whatever it is, you can ignore that, and 1 into 2 power minus 3 is actually 0.125. So this is 2 plus 1, 3.125. 0.5 plus 1, 0.625. Okay, so it is 3.625. The equivalent number for this in decimal system is 3.625. We will also cross check in the reverse way. That means let us take 3.625 and we will convert that into 11.101 and we will see whether it is correct or wrong. Okay. So 3.625, leave that 3 as it is for now. You know what is 3 in the binary system? It is 2 ones and this is 1. The remainder is 1. Okay. So 3 is equal to 11 in its binary system. Now come to the fractional part. 0.625. 0.625 into 2. 0.625 into 2. What is that? 6 2 5 2s, 5 2s 10, 2 2s 4 5, 6 2s 12. So it is 1 2 3 1 2 3. It is 1.25. It is 1.25. 0.625 into 2 is 1.25. Okay. So what you will do now? Write this number here. Write this number here. And write this decimal part, that is fractional part here. 0.25. Once again into 2. You will get it as 0.5. This 0 will be here. And this 0.5 will come here. Multiply with 2. You will get it as 1.0. Write this 1. And as it is 0, stop. So this 0.625 equivalent is 10101. Okay, so it is 11.11.101. That is the equivalent binary system for the number 3.625. The same thing which we got. Yes, so this is correct. Okay, so once let us have a quick revision of what we have discussed in today's class. Okay, so what we will do quickly, we'll see some more examples. Okay, so let us take 36. It is 2 18s are and we left with remainder 0. 2 9s are 18, remainder is 0. 2 4s are 8, remainder is 1. 2 2s are 4, remainder is 0. 2 1s are 2 and the remainder is again 0. So we'll get this number as 1 0 0 1 0 0 1 0 0 1 0 0. So this is the equivalent binary number for the decimal number 36. Let us also check in the reverse way. That is 1 0 0 1 0 0. This is multiplying with 2 power 0. That is 1. This is with 2. This is with 4, 8, 16 and 32. Okay. So add all the ones. Wherever we have 1, add all those numbers. That is 32 and 4. 32 plus 4 will give you 36. The same number here. Clear? This is converting from a binary to decimal as well as from a decimal to binary and binary to decimal. The same way goes for its fractional part. The same way will be with its fractional part. Let us say 0.625. 0.625. In the decimal system, we need to convert it into binary system. What we will do here? Okay, so 0.625 into 2. 0.625 into 2. What it is? 6 2 5 2s, 5 2s 10, 2 2s 4 5, 6 2s 12. So it is 1.25. And write that significant figure, that is 1 here and 0.25 here. 0.25 into 2 will give you 0.5. Write this 0 here and this 0.5 here. 0.5 into 2 will give you 1.0. Write that 1 here and you can stop it there. So this is equal to, in the decimal system, this is equal to its binary 0.101. 0.101. Clear? If you want to write this one, 1111.101. Okay, so this number you try to calculate, this will be 15, as we have already discussed in the first example, 15, and this 0.101 will be equal to 0.625. So it is 15.625. So this is about the basics of how to convert a binary number to its decimal or decimal to its binary number. So in the next lecture, we will be discussing about the algebra of binary system, that is addition, subtraction, multiplication and division. Thank you so much. We will meet in the next lecture.